So if I do it this way first, it'll be y minus what? 6 equals 3 times x minus 4. I like it. So I get y minus 6 equals 3x minus 12. Add 6, I get y equals 3x minus 6. That's what all you guys should have gotten. Now obviously that's also what you guys should have gotten. It just didn't look like that till the end. So on this side, we would have put y minus negative 3 equals 3 x minus 1. That looks totally different, right? So I get y plus 3 equals 3x minus 3. Subtract 3, I get y equals 3x minus 6. Same thing, of course. There's one equation for a given line. If I have an equation where I could put a point in, well, how many points could I use? An infinite number. Any of them should give you the same equation because that line has one equation. So you already got 2 points. Of course, either one of them is going to give you the same equation. All right, let's step it up. Next level. There's always another level. Sorry, Mario, your princess is not here, so I got to go to the next level. It's going to be something like this. Find the equation of the line. I like you. You're pretty good. Damn it, you can't get higher. Find the equation of the line. This should sound a little familiar. Goes through negative 4, 7, and is parallel to, I don't know, Jeff, 2x minus 3y equals 7. So my suggestion to you, the thing about math, the thing about all math, is the people that are naturally able to see parts of something, they're just the lucky ones. They're the ones that are just able to do math better. Because the more you can break things down into little parts and then put them back together, the easier all of it is. So that's why I try to show you. When you see this, find the equation of the line that. Don't give a shit about that yet. What 2 things do you need? Slope, point. Then you focus on, okay, did they give me a point? Yes, thank God. I don't have to find it somehow. I got the point, check. Did they give me a way to figure out the slope?
Yes.
Shit, yeah, so go ahead and do that. The soundtrack of this class.
Straight up.
Huh?
That's totally true.
I don't want to jinx us, but I have to say, we haven't had like 3 of them go on at once or something. Thanks, Jeff. That's going to happen. What are you guys doing to get the slope? Subtract 2x. If there's still anybody that thinks that's 5x, come see me. These are not like terms, right? But I still have a few people that are telling me that's like 5x. This is going to be negative 2x plus 7. You can't put them together. And then what's the last thing here? So what's this guy's slope? 2/3. So what's my slope? 2/3. I love it. Be really careful. It's a parallel. So same slope. That kicks ass. And now it's what I call, yeah, you wouldn't do that. Why? Because they didn't say they were.
Oh, sure.
I'm with you, don't worry. We did one earlier that was perpendicular, but you got to really pay attention. You got to be careful. Your brain will just kind of take over. You're like, stop. Now we're at a level that I used to always call the STT level. Once you get these two things, you do the same damn thing. You plug them in the equation, right? I don't care where they came from. I don't care what weird shit I told you to do. Once you get these two things, forget all that shit. Just plug it in the right place. We know the two things I got to know. So what goes here? 2/3. What goes here? 7. What goes here? Yeah. You're going to love it. Go ahead. Solve for y. It's going to be yummy fractions in there. We haven't done enough fractions recently. Let's do some more of those. Jamie? Jamie! Crystal? Fred? Monique? Liam? Liam! Sure. Darry, I think, is... Yeah, okay. So this is going to be plus 4, right? So y minus 7. 2/3 x. 2 times 4. 8/3. And then last step is to add 7. So of course I need LCD. So I'm going to multiply this one by 3. So you get 21 plus 8, and get 29/3. Wow! Pretty gross. How do you check that? At least to a certain level. What's supposed to be true about this? If I plug in -4, 7, it's got to be true. All right, so if you plug in a -4 here, -4 times 2 is -8, plus 29 is 21/3. 21 divided by 3 is 7. It works. When I plug this in, this comes out. That's a nice, quick little check you can do. Yes?
I'm sorry, can you repeat that?
Yeah, if this line is supposed to go through this point, what does it mean algebraically? The x and y values should work in the equation of the line. Because that's what it means for a line to go through a point, is that point works algebraically in the equation. Those two things mean the same thing. If it works, the line goes through it. If the line goes through it, it works. So that's the way you check it. It's supposed to go through that point, just plug it in. Okay, I like it. So one last thing for today. And actually, it's not even going to be the full thing. It's just too much. This, let me see if you guys know this already a little bit. I just want to stop recording, but I won't. The idea of functions. So, when I say I have a function that I'm working with, there's a very specific meaning. So when I'm talking to another math person, which you all are becoming math people, we know, when I say I have a function I'm working with, we all know what it is I mean. The thing with functions are, here's an example of something that's not a function. This is not a function. So one nice way to look at a function is it's got to make physical sense. So if I throw a ball and I say 2 seconds later, where's that ball? Well, it better be in one place. So if the graph looked like this, where's the ball 2 seconds later? Well, it's there and it's there. What happened to that ball? Somebody just like, shut, right? And it's like, wow. No. Time warp, those things happen. Huh? But no. At 2 seconds, it cannot be at 2 different places. Does that make sense? I like it. So there is a physical kind of component to this. A function has to be something that when graphed makes physical sense about, for example, location, right? So this wouldn't make sense because it would say at this time it's under the ground, up there, and even higher, all at the same time. So what does this mean? The whole thing I'm looking at is this x value, right? In order to be a function, the x value can only have one y value. Anybody ever watched Highlander? Yes, okay, Ben. There can only be one, right? There could be only one. So the definition, the formal definition of function is for every input, which is normally x, for every input, there can be only one output, which very often is y. Now we saw an earlier example. Remember that one we did earlier where it was T and W, the one about the dying from cancer. Okay. Yes. No. So graphically, it's really quick to tell. In fact, what would you say to me? Why is this not a function? What's the quick way to say it visually? Because, yeah, well, it does. If I draw a vertical line, it goes through more than once. Right? And what is that? How does that relate to this? For the input x, some x equals a number. That's a vertical line. Is x equals. Remember we did those two special cases. Y equals, x equals. So for that x value, it's got 3 different y values, 3 different outputs. That goes against the definition. It's not a function. So if any vertical line goes through at most once, it's a function. So would this be a function?
Yes.
Totally. It looks like the Loch Ness Monster function, but yeah, that's a function because any vertical line I could draw would only go through once. It doesn't come back on itself and try to exist in 2 different places at once. I like it. All right, let me show you a different view of this. Does this describe a function or not? Somehow I'm claiming this is the exact same idea that we just spoke about visually. This is obviously not so visual. But what's the main idea for this? Any x value cannot have more than one y value. So does that happen here? Is there an x value that has more than one? Yeah, because 2 has an output of 7 and 9. It's like you're person 1 and you're person 2, and I say, person 2, what size shoe do you wear? And you say 7 and 9. Right? If I'm very specific. On your left foot, because I understand maybe feet could be very different. On your left foot, what size shoe? 7 and 9. I'm like, what the shit are you talking about? Of course, she's got flip-flops on that, so you still have the size, right? Yeah. So this one is not a function y. X value 2 has 2 outputs. So visually, it's the vertical line test. If they give you a collection of points, what was this quick way to look here? I had an x value that repeated. So would this be a function? Would this one be a function? Probably yes, right? Let's see if you guys get this. Is this a function? Totally, all that it is. Is there any x value that has more than one y value? 2 only goes to 7. Negative 3 only goes to 7. 5 only goes to 7.
So the y doesn't matter.
The y doesn't matter. So again, why does this make physical sense? If there's a ball sitting 7 feet up and nobody does anything to it, 3 seconds later it's still at 7 feet. Does that make physical sense? Yeah, totally. It's not in 2 different places at once. It's just sitting at 7 feet up. Just sitting there, that's all that means. So for every x, there can be only one y. So 2 only goes to 7, negative 3 and so forth. I like it. Okay. Yeah, I think this is enough for today. So next time we'll finish up section 3.8. This is section 3.8. After that quiz, and then I got a little group worksheet. And that, I'm sorry, Monday is when the quiz is happening. Tomorrow there's no quiz. We'll finish up section 3.8, get into chapter 4. High school. Yeah. Perpendicular? Oh, ERP. ENPICULAR. No, there's no E there. Just IC. Perpendicular.